Let us now have additional examples wherein trigonometric substitution is applicable. Let us consider the integral of x cubed square root of 4 minus x squared dx. For this problem, you're going to see that there is this term 4 minus x squared. This is resembling an a squared minus u squared. So a squared minus u squared arc sine. So therefore, we're going to set a squared is equal to 4 and x squared is equal to u squared. So we have a is equal to 2 and x is equal to u. For a squared minus u squared, we should use u is equal to a sine theta. So therefore, we have x is equal to 2 sine theta. From that, we can also have its derivative dx is equal to 2 cosine theta d theta. From this as well, we will be doing our substitution such that we have 2 sine theta cube square root of 4 minus 2 sine theta squared dx. And our dx is 2 cosine theta d theta. So that would be integral of 8 sine cube theta. And then we have, for this term, we have 4 minus 4 sine squared theta times 2 cosine theta d theta. We factor out 8 and 2, so we have 16 integral of sine cube theta and then square root of 4 times 1 minus sine squared theta. And then we have cosine theta d theta. We have the identity for cosine squared theta, which is equal to 1 minus sine squared theta. So we can simplify this as 16 integral of sine cube theta. Square root of 4 is 2. 1 minus sine squared theta is cosine squared theta. And the square root of that would be cosine theta times cosine theta d theta. If we have an odd power of sine or cosine, we split up that expression from the integral. So we will be having 16 times 2, so that would be 32. Integral of sine squared theta, cosine squared theta, and then we have sine theta d theta. We set our u to be equal to cosine theta such that our du would be negative sine theta d theta. So take note that we should be having negative sine theta d theta. So we multiply it by negative 1 and multiply it again by negative 1 so that we will be not changing the problem. So we have negative 32 integral of 1 minus sine squared theta. It should be so this is your du This is a u squared. So, this must be a function of u. So, in simplifying this, we're going to have 1 minus cosine squared theta times cosine squared theta times negative sine theta d theta. So we have negative 32 integral of 1 minus u squared times u squared du. So we have negative 32 integral of u squared minus u to the fourth du. So the integral would now be equal to negative 32 u cubed over 3 minus u raised to 5 over 5 plus c. So take note that this is about radicals, square root. So we might as well write u with even exponent and factor out the odd exponent. So we can rewrite this as negative 32 u, and then we have u squared over 3 minus u raised to 4 over 5 plus c. So that would also be negative 32u, and then we can have the LCD equal to 15. So we have 5u squared minus 3u to the fourth plus c. So we have negative 32 over 15. U is the square root of 4 minus x squared. And then we have 5u squared. So u squared is equal to cosine squared. Sorry, we're not yet there. So we have negative 32u times negative 32u over 15, 5u squared minus 3u to the fourth plus c. U is cosine theta. So we have negative 32 over 15 cosine theta times 5 cosine squared theta minus 3 cosine to the fourth theta plus c. We now solve our triangle. So we have sine theta is equal to x over 2. So for our right triangle with an angle theta, sine theta is opposite over hypotenuse with the opposite x and the hypotenuse 2. The third side would be the radicand. So that would be the radical square root of 4 minus x squared. Hypotenuse squared minus the other side squared. So 4 minus x squared. So we can now solve for cosine theta, which is equal to adjacent square root of 4 minus x squared over 2. So we have negative 32 over 15 cosine square root of 4 minus x squared over 2 times 5 cosine squared theta. So that would be 4 minus x squared over 4 minus 3 times 4 minus x squared over 2 to the fourth. So 16 plus c. So we now have negative 16 over 15 square root of 4 minus x squared times 5 over 4 times 4 minus x squared minus 3 over 16 times 4 minus x squared plus c. For our next problem, we have dx over 25 plus 16x squared raised to 3 over 2. So here, we have 25 plus 16x squared, which is a form a squared plus u squared. A squared is 25, while u squared is 16x squared. So a is 5 and u is 4x. If we have an a squared plus u squared, we use u is equal to a tangent theta. So we have u is 4x equal to 5 tangent theta. So x is 5 over 4 tangent theta, and dx is 5 over 4 secant squared theta d theta. With this, we can now do our substitution. By the way, if we want to solve for tangent theta later, it would be 4x over 5. And your tangent theta is opposite over adjacent. The opposite side is 4x and the adjacent side is 5. The hypotenuse would be the square root of a squared plus b squared, the square root of 4x squared plus 5 squared, which is this expression. So square root of 25 plus 16x squared. With that, I think we're ready for the substitution. Dx is 5 over 4 secant squared theta d theta all over 25 plus 16 times 5 over 4 tangent theta. And then we square this. We raise this to 3 over 2. So we have the integral of 5 over 4 secant squared theta d theta over 25 plus 16 times 25. So I think this is squared. So 25 over 16 tangent squared theta raised to 3 over 2. So this is the integral of 5 over 4 secant squared theta d theta all over 25 can be factored out, and we have 1 plus tangent squared theta. We raise this to 3 over 2. Take note that 25 is equal to 5 squared, and 1 plus tangent squared theta is equal to secant squared theta. So with this, we have the integral of 5 over 4 secant squared theta d theta all over 5 squared square root, so that's 5 cubed times 1 plus tangent squared theta is secant squared theta. So secant squared theta square root, so that would be secant theta raised to 3. So that would be secant cubed theta. We cancel out secant squared with secant cubed, so what's left is secant, and then 5 and 5 cubed, so we have 5 squared. So this would be the integral of 1/4 times 1 over 25, 1 over secant. So 1 over secant is cosine theta d theta. So that would be 1 over 100 integral of cosine theta d theta. The integral of cosine theta d theta is sine theta plus c. So we have 1 over 100. Sine is opposite over hypotenuse. So that would be 4x over square root of 25 plus 16x squared plus c. So we can cancel out 4 and 100. So we have x over 25 square root of 25 plus 16x squared plus c. And that would be our final answer. So we get the value of sine theta here, which is opposite over hypotenuse. So sine theta is 4x over square root of 25 plus 16x squared. Next, let's have integral of dx over 4x squared minus 1 raised to 3 over 2. So, this integral has 4x squared minus 1, which is a u squared minus a squared. Your u squared is 4x squared and your a squared is 1. So your u is 2x and your a is 1. A u squared minus a squared, so that means we use u is equal to a secant theta. So your u is 2x equal to a, which is 1 secant theta. So your x is secant theta over 2 and your dx is 1/2 secant theta tangent theta d theta. So integral of dx 1/2 secant theta tangent theta d theta, and we divide this by 4 times x. X is secant theta over 2 squared minus 1 raised to 3 over 2. So we have the integral of 1/2 secant theta tangent theta d theta all over secant theta squared is secant squared theta. 2 squared is 4, so 4 over 4 would cancel out. Minus 1 raised to 3 over 2. Tangent squared theta is equal to secant squared theta minus 1. So therefore, we have the integral of 1/2 secant theta tangent theta d theta all over tangent squared theta raised to 3 over 2. So tangent squared square root, so that's tangent theta cube. So we have tangent cube theta. We can cancel this. What's left is tangent squared theta. We express everything in terms of sine and cosine. So we have 1/2 1 over cosine theta. And then we have 1 over tangent theta. So 1 over tangent squared theta rather. So that would be tangent theta is sine over cosine, but it is at the denominator, so cosine over sine squared. So we have cosine squared theta over sine squared theta d theta. We can cancel out this and then separate the sine thetas. So we have 1 over sine theta and cosine theta over sine theta d theta. So the integral would be the integral of cosecant theta, cotangent theta, d theta. The integral of which is negative cosecant theta plus c. Let's form our triangle. So we have secant theta is 2x over 1. So secant theta is equal to 2x over 1. So our triangle would be with an angle theta. Adjacent over hypotenuse is for cosine. For secant, it would be hypotenuse over adjacent. The hypotenuse is 2x. The adjacent is 1. So we have here 2x squared minus 1. So observe that it would be the term that we are considering earlier. So cosecant is hypotenuse over opposite. So negative hypotenuse 2x over square root of 4x squared minus 1 plus c. And this is our integral. Let's have our next problem. Integral of dx over x squared, square root of 4x squared minus 9. So we have the radical 4x squared minus 9. And this is resembling a u squared minus a squared. So our u squared is 4x squared and u is equal to 2x. 9 is equal to a squared. So a is 3. If we have u squared minus a squared, we use u is equal to a secant of theta. So secant theta is u over a. U is 2x. A is 3. So 2x is equal to 3 secant theta. X is 3 over 2 secant theta. Dx is 3 over 2 secant theta tangent theta d theta. Dx is 3 over 2 secant theta tangent theta d theta over x squared. So that's 3 over 2 secant theta squared. Square root of 4, 3 over 2 secant theta squared minus 9. So we have 3 over 2 secant theta tangent theta d theta all over. So we have 3 over 2 secant theta, 3 over 2 secant theta. So we can cancel this. And then square root of 4 times 9 over 4 secant squared theta. So we can cancel out 4 and then we subtract 9. So that would now be integral of tangent theta d theta over 3 over 2 secant theta times square root of 9 times secant squared theta minus 1. Take note that tangent squared theta is equal to secant squared theta minus 1. So therefore, we have the integral of tangent theta d theta all over 3 over 2 secant theta. Square root of 9 is 3, and this is tangent squared theta. Square root of that would be tangent theta. So we can cancel out tangent theta. So we have 2 over 9 integral of 1 over cosine theta d theta. So 2 over 9 integral of 1 over secant theta. So 2 over 9 cosine theta d theta. So we have 2 over 9. Integral of cosine theta would be sine theta plus c. And since 2x over 3 is secant theta, that would be hypotenuse over adjacent. And the third side would be 4x squared minus 9. So, the radical. So, we have now 2 over 9. Sine is opposite over hypotenuse plus c. So we have square root of 4x squared minus 9 all over 9x plus c. Now let's have our next example. So for this case, we have x squared plus 2x plus 5. This is also equal to x squared plus 2x plus 5. We are going to add 1 so that it would be a perfect square, x plus 1 squared. And since we add 1, we also subtract 1. So this becomes an x plus 1 squared plus 4, which is 2 squared. So this is a form u squared plus a squared. So u is x plus 1 and a is 2. We use u is equal to a tangent of theta. So x plus 1 is equal to 2 tangent of theta. Dx is equal to 2 secant squared theta d theta. So this would be the integral of 2 times x. X is 2 tangent theta minus 1 plus 3 dx. 2 secant squared theta d theta. We're going to use the factored form or the completed square, this one. So that would be x plus 1 squared plus 2 squared. So we have 4 tangent theta minus 2 plus 3 times 2 secant squared theta d theta over the square root of x plus 1 squared, so that's 2 tangent theta squared plus 2 squared. So we have 4 tangent theta plus 1 times 2 secant squared theta d theta all over square root of 4 times tangent squared theta plus 1. So we have 2 times 4 tangent theta plus 1 secant squared theta d theta. So we have factored out already that 2. Square root of 4 is 2, so we can cancel out with this one. And tangent squared theta plus 1 is secant squared theta. Square root of that would be secant theta. So we can cancel out one of this. So we have the integral of 4 secant theta tangent theta plus secant theta d theta. So that would be 4 secant theta plus ln of secant theta plus tangent theta plus c. We form now our triangle. Tangent theta is x plus 1 over 2. And for tangent, it is opposite over adjacent. Opposite would serve as your x plus 1 and adjacent is 2. So for the hypotenuse, we apply Pythagorean theorem. We have x plus 1 squared plus 2 squared, which is this one. X plus 1 squared over 2 squared. So we need a secant theta. Secant theta is hypotenuse over adjacent. So that's square root of x squared plus 2x plus 5 over the adjacent 2. And for tangent theta, it is opposite over adjacent. The opposite side is x plus 1. The adjacent side is 2. So we now have 4 secant theta square root of x squared plus 2x plus 5 over 2 plus ln of secant. Secant is square root of x squared plus 2x plus 5 over 2 plus tangent theta x plus 1 over 2 plus c. So we have 2 square root of x squared plus 2x plus 5 plus ln of square root of x squared plus 2x plus 5 plus x plus 1 all over 2 plus c. And that's our examples for trigonometric substitution. You may play this back at a lower speed or you pause anytime some unclear points were given. Thank you. Bye-bye.